This video is an advanced ChatGPT guide as well as a manual on how to use OpenAI's API platform. I created a video for the basics, which you can find just up here. Because this video is more of the advanced topics, I'll just begin with what they are and how this video will be structured. It'll be done in 3 parts. The first will be the advanced prompt engineering that we'll be doing with ChatGPT. This is how to get the kinds of prompts and outputs that you want, not just the mundane examples where people are just chatting to it. The second part of the video will be jumping into the playground and really taking a closer look at the different types of models that OpenAI provides. All of them work a little bit different, and it's really important to know the difference. And finally, we'll build an application. This application will be an API running on NodeJS using JavaScript. It's going to be able to query the OpenAI API layer, and it's going to create prompts and pull out outputs that we want. Quick pause. I'm going to sponsor myself in this video. I've put together a template that's ready to go. If, for example, you're looking to create a project using OpenAI and even create an idea behind it and even sell it as a SaaS, because I've created a template built on top of React and Node.js with the APIs ready, with authentication, automatic calculations of token usage, and all of this is ready to go for you guys to use. And I'll be transparent on the pricing. This took me over 100 hours, which means that if I was billing at $20 an hour, then it'd be over $2,000. But I'm putting it up for $500. It means that you get to save yourself 100 hours or more, depending on how long this would take you. And hopefully it gets you up and running nice and quick. So without further ado, let's begin this video. Prompt engineering is the very first thing that I want to talk about, and probably the most important whenever working with any type of AI. This part that you'll learn right here will be applied to most AIs that you use. So whether it's going to be image generation or text-based generation or even ChatGPT, understanding these principles will be applied throughout. So what is prompt engineering? It's essentially querying an AI in the most effective manner to get the desirable outcome. Now, this seems pretty self-explanatory, but when working with something like a chat AI, we might commonly just ask it to do things the way we would normally ask a person. Unfortunately, an AI works a little bit different. So while most of the time you'll still get an answer, you can get a more desirable answer if you structure your prompt quite effectively. The first prompt I've created here says, on average, Joe asks 35 questions to ChatGPT per hour. How many questions does he ask in a standard workday? ChatGPT provides a pretty standard answer here of 280. That seems reasonable, but this isn't very useful. Here we can begin to see prompt engineering in action, because we're going to take a look at my second example. Here, I'm going to ask the same question, but I'm going to follow up with show the answer as a math formula inside of a code snippet. The answer is essentially the same. It's 280, but now we get some working happening here. We have a variable here called questions per hour, a workday length, and the query that creates it, and finally it prints it out. Of course, we can go even further than that. We can create this as a code snippet using JavaScript specifically. As you can see, I'm engineering the prompts here to be more and more specific depending on the outputs that I want. This is prompt engineering. In a casual sense, it means that sometimes you have to redefine what you're asking to get the optimal output. In this case, my optimal output was having this structured as a JavaScript query, or even better than that, as a function. I can give you lots and lots of examples like this, but realistically, you do have to play around because every single use case will be a little bit different. The goal here is to continuously create better and better prompts until you get that desired outcome, and don't simply assume that maybe the AI cannot generate it. Of course, this is a more advanced video on ChatGPT as well as prompt engineering in general. And in order to better understand all these concepts, it's beneficial to log into the OpenAI website and head over to its main dashboard here. Here you have this page called examples, and under examples, you're going to get lots and lots of different ways that you can utilize the AI to complete different tasks. What's useful here is that OpenAI has gone in and actually engineered some of the best prompts as well as responses that ChatGPT or any of the other models can produce. So going through all of these, understanding how they work, as well as testing them out yourself will be a perfect way to learn prompt engineering. I'm not going to go through all of them. I'll just go through 1 or 2 to give you a better idea of prompt engineering in general, and this should give you a broader view of how to structure your own prompts. The first example here is one of the best for prompt engineering. It's called questions and answers. And there's a few things happening here. I'm going to open this up in the playground, which we'll be looking at shortly, but it should be a prime example of how you can start engineering prompts even inside of ChatGPT. We're going to be doing a number of things here. The very first is this section just over here. This is saying that I am a highly intelligent question answering bot. It's priming ChatGPT, or in this case, the model Text Davinci 003, as to what it's doing. It's going to ask questions and answer truthfully with responses of unknown if it doesn't know what it's doing. But there's more to this. There's a few examples that we're going to provide it as to how we want it to answer. The first says, what is the life expectancy of someone in the United States? Rather than just saying 78 years, we're priming it to give a more lengthy and human answer of the human life expectancy in the United States is 78 years. This means that in future example responses from the AI, we're going to get more lengthy answers. And this is sort of how we're priming these prompts. The more examples that you provide ChatGPT, or the more examples you provide any AI, the more it writes in tune with that same language. Here I'm going to ask the model how many years it's been since the US was founded. It's going to say 244 years since the US was founded. Unfortunately, this actually might even be incorrect because of the fact that the AI model is out of date. But this gives you an answer that basically is very similar to the past examples. This is an example of how we're priming the AI to provide us answers that we want. Rather than a long description or an essay, we're asking it for short, very specific questions with short, very specific answers. Let me go back to the examples over here, and this time I'm going to go to another one that I kind of like called the Airport Code Extractor. This one has a lot less examples because it's much simpler to create. It simply extracts the airport codes from this text. Now, this is the context we're providing to the AI as to what we want it to do. Then we have a working example. We've got the text, which is I want to fly from Los Angeles to Miami, and the airport codes, which are, well, I suppose LAX and MIA. Then we've got our second example here, which we can immediately submit, and we get the results we want from the examples we had previously. Let's see how this would look inside of ChatGPT. I'm going to remove this and copy this into a brand new session or a brand new chat. Here, I'm going to paste it in, and let's see what the response is back. Here, we should essentially get the same sort of results, but because ChatGPT is primed slightly different to always have answers more like a chatbot, it isn't exactly the same, but it more or less is. But hopefully this gives you an idea of how ChatGPT is technically just like that playground interface that we've been just utilizing. Now, these are also kind of basic examples. If we want a more advanced example, let's take a look at this SQL Translate one. If I open this up in the playground, we're going to see very similar context to what we saw previously. The context here being this is a PostgreSQL table with their properties. Then it follows on with that actual table and the specific properties. And then finally, we have a query. The query is to list the names of the departments which are employed by more than 10 employees. And it preps a select query here for that. This is now quite easy from that context for the OpenAI. Well, I believe this model is called Code-Davinci-002. It's more specific for code to provide this code example. And I suppose this is where we start moving away from prompt engineering to having a look at the different models that OpenAI provides us to engineer different types of outputs. Because so far, ChatGPT is only just one model, but there are a lot more. Before we get into that, if you want more information about prompt engineering, if this still wasn't enough, there's an entire section here under documentation, guides, and introductions where you'll get to learn about how to do prompt design for basic things like show and tell or providing data. If you want to do things like classification or, for example, generating text, or even doing conversations or transforming different bits of information. It really depends on what your use case is, but there's a lot of information that is worthwhile for you to read and go through here. We're going to take a look at models now. This is the second part of this video, which I think is very important to understand, because when you're going to be using OpenAI and any of its features, you're going to be utilizing different types of models. ChatGPT is technically one type of model, one specific type made for the general public, and because of that, it's also limited in a way because it's been pre-designed to be very safe, very simple, and it might not have the best outputs that you want. This is why understanding the different types of models that OpenAI provides is the beneficial way to create the types of outputs that you want, depending on what you're building. So what is a model? It's essentially the AI and how it's being trained. Very similar to how we prime the AI to information we want in the prompts, so are models primed to the way that an AI works. GPT-3 is what most of the models are based on. But there are 4 main different ones, which are worth knowing. There's Davinci, Curie, Bug, and Ada. They all have different prices attached as well, and complete different tasks. Let's take a look at our very first and most powerful one, which is Davinci. Davinci can do complex intent, cause, effect, summarization, and much more. It's the one that most things are based on, probably ChatGPT as well. It's able to create very good blogging and outlines and lots more that especially do with creativity. The next one is Curie. It costs a little less than Davinci and is a little bit simpler. It still does things like language translation, classification, segmentation, as well as summarization. But it will need more training data to be able to perform the same sort of functions as Davinci does. Next, we have Ada and Bug. Ada is the simplest and cheapest one to use. It does very simple things like parsing text, classification, address correction, and keywords. It basically does these tasks very quickly, but it needs a lot more training to be able to perform at the same accuracy level as models above it. Bug is a more or less in between Curie and Ada, but it does things like classification as well. There are the Codex models. Now for the Codex models, we have Code Davinci 002 and Code Crushman 001. Both of these work a little bit different. Crushman is slightly more capable than Davinci, and it's slightly faster too, but it's very simple in its task, where Davinci is more of a language model that also can do code, so you can ask it more vanilla questions like you would in ChatGPT. And finally, we have here one called the content filter, and this might be something you've stumbled across when you've generated a prompt on ChatGPT that might have been malicious or harmful in a way, and suddenly it gets blocked. This is because it's gone through the content filter model and it's been deemed unsafe, and therefore that information gets blocked away. As I mentioned before, there is pricing attached to all of these models. You might have seen it before if you go to OpenAI pricing and have a look at the image as well as language-based models. Here you can see Ada, Bug, Curie, and Davinci, and their pricing attached per token, per 1,000 tokens to be specific. 1,000 tokens is about 750 words. So one paragraph is maybe say 35 tokens, and a token is approximately 4 characters or 0.75 of a word. It's essentially how the model has been trained, but it's a complex thing. If you want to learn more about tokens and pricing in general, let me know in the comments below. There's also this tool here that tells you exactly how many tokens you've used and what that looks like from the AI model. Now, we know a little bit more about the different types of models. We know about the different types of costs. What does this look like in a practical sense? What do these models actually output in comparison to each other? Let's take a look in the playground before we move into the coding segment of this video. Let me start off with a pretty simple example. I'm going to select the SQL Translate, which we looked at earlier. This currently uses the Code Davinci Model 2. If we select to finish the statement off, it gives us a very good piece of code, but this is because it's primed to do so. If we were to open up our text Ada 001 model and ask for the same thing, the response would look very different. It would not even be able to fill out the full response like we had previously. And here you can see that it hasn't done a very good job. This is where we might need to give Ada a few training examples of what we want to do, but Ada isn't the best model for this kind of work. If we actually go back to our examples and try another one, such as Curie, it might be closer to being able to create such an output, but again, it's kind of still far away from it. It doesn't really understand what it's looking for, so it can only extrapolate with limited information. This is where models such as even Text Davinci would do a much better job. While it's not a say, model for programming, it does have a lot more to based on because Davinci is a more expensive model trained on larger sets of data. And this is what I mean by these models, essentially producing different types of outputs. Of course, Davinci will always provide the best type of outputs. But for example, Crushman here might also produce a very good output for this type of query. And as you can see, it did so very quickly too. There's one other important thing to take a note at when working with a lot of these models, and it's the temperature. I would say this is one of the most important characteristics to play around with. And I'm going to showcase how it works in different ways. But temperature is essentially the randomness that the AI outputs based on its models, with a 0 being that it is very strict with the information, whereas a 1 is meaning that it is very creative and open to suggestions. This is interesting because we'll take a look at how this works in principle. Here we're using Text Davinci with a temperature of 0, and we want to fix the grammar of this sentence. So it's a very simple structured thing that we don't need any creativity for. We simply are fixing the text. Whereas, for example, something like summarization of a second grader's description here of Jupiter, this needs it to be a little bit more creative. So it's on about a 0.7 on the scale here. One of the limitations to ChatGPT is that the temperature is probably locked in to what the actual model is set to. Whereas if you're building your own model, or even if you're, for example, using one of the models here, you can define the temperature depending on the prompts and outputs that you want. It gives you a lot more fine control. There are, of course, a few other variables that you can utilize here, and if you want to investigate and learn all of them, let me know because I might do another video on them, but this can get very complex very quickly. I want to create an advanced course, but not an expert one. Maybe that's an entire different video. There is one final thing that I want to let you guys know about models, and it's the fact that these are not just the only ones. You can actually fine-tune your own model. This is complex, and I could do a whole video on this, but it essentially means that you're training a model to perform the functions exactly how you want. It ends up being a little bit cheaper because you're preempting that model to work how you want. There is a whole guide onto how you can do this, which I won't get into right now, but I'll link in the description below. So far, we've taken a look at prompt engineering, how to create prompts that provide ChatGPT or GPT-3 or any of the other models with the context of what they're doing, examples of how to do the thing, and then produce the outputs that we want. We've had a look at the different types of models because they all work a little bit different, with Davinci obviously being the best. Now it's time to jump into the technical part where we interact with the models from OpenAI through its API layer and create our own API to start interacting with, I suppose, our own customers. Let's begin. You're going to need a few things to get this project up and running. The very first will be a copy of NodeJS of the latest stable version. I think I'm running 18.12.1 at this time. The next thing we're going to use is create React app. So with create React app, this is going to basically be the front end for our website. We're going to pull this in, and then finally we'll be using Express for the backend. Finally, you'll need to have an instance of OpenAI signed in, and you'll need to be able to identify and utilize your API key. We'll get into that shortly, but after you've logged into OpenAI, you'll want to head over to the documentation and then over to the API reference guide. Here, there'll be more information if at any point you get stuck. The first thing I'm going to do is open up VS Code now, and I'm going to run npx create react app, and I'm going to create an app called the, I suppose, Chat GPT API SaaS. Seems like a pretty good enough name. I'm going to select yes to proceed, and this will kick off the front end, which we're going to use. But I'm going to make this also the back end, and it's going to work in a dual sort of nature. To make life easier, I'm just going to open the folder here and browse straight into it. It's a pretty standard package, and I should be able to just run npm start and we'll get an instance of create react app. Here it is, running quite well. The next thing I want to do is create a web server. And this is going to be in a file called index.js, and it'll be the backend server where the API requests happen. I'm going to use GitHub Copilot to write this, but I'll also explain what's happening in the background. I'm going to use a Express server, which will handle API requests coming in and respond back with a JSON object. It will use body parser as well as cores. So we'll start off with a const require. It's going to require express. We're going to also require body parser. We're going to also require cores, which I forgot to install. We'll define app equals express. We'll define the port. Then what we'll do is add body parser.json to the app. We'll also add cores, which we'll install shortly. After that, we'll define our first route, which will be a simple hello world, which I'll define just over here. And I think we could just listen to it to test it out now. So let me finish this off. Now, all we have to do is actually run it. So here, inside of console, I'm going to run node index.js. We are missing cores, so let me actually install that. npm install cores -- save. And with that, let's just run node.index.js. It's running on port 3000. We can click it and we've got our hello world request there. Perfect. Now let's head over to src and head over to app and let's delete everything in there. We're going to use GitHub Copilot to create our React component here. What I'm going to do is say create a React component that inputs a text area message, then performs a fetch request to local host 3001, gets back a response as a data.message and displays that message in a box below. Now that's pretty descriptive. Let's see if it can do that. So we're going to preempt it here with import. It'll import React with useState. It'll create the function for app. And this might take a little bit because it's a bit of a large app, but here it's created one. If we look closely, so let me actually close off the menu here. We've got message, set message, response, set response. We're calling a fetch request here on a handle submit as a post, and we're applying here a JSON object. We're stringifying that with the message here. We're then also passing and saving that response just over here. Here we have a text area, which we're setting the message and we're doing a submit. And here we're grabbing that response from that form. So I think that's all good. I'm going to hit save on that. The only thing I feel like I'm missing here is an export default app, which I think it might have forgotten. And I think it's, yeah, the rest looks good. Here, heading back to index.js, we probably want to change the port to 3001. We want to change this response here to send over a message saying maybe something like hello world. And we want to change the get request to a post request. Hit save on that. We're going to probably have to relaunch it now because we've made changes. So I'm just going to run index.js over here. And now we should be able to refresh the browser, type in anything in this box, submit, and we get a hello world from the web server. Now our front end and our back end are working and connected. Now comes the fun part. We're going to import, well, OpenAI and GPT-3 and its models and start using them. I'm going to head over to the website to start off with, and we're going to head over to the introduction for the API and scroll down here to importing it. I'm going to import it into our Node.js index.js file here at the very top. And this is using an import statement, which we can't technically use because I haven't set the types for that. So I'm going to just do const and we're going to do configuration. Actually, we'll do something like OpenAI is equal to require OpenAI library. So I think that's okay. Now here I'll do some decomposition and I'm going to pull out configuration and OpenAI API from OpenAI. And I'm going to pull these through const. So that's pretty standard. Then I can delete the import statement and we can move on to the next part. Now we've got a few other things happening over here for the configuration. We've got the organization ID as well as the OpenAI key. Then we're setting this under the variable here, OpenAI, and we're doing a response to pull in the engines, which I'm going to skip for the time being. But we need this API key, which I recommend under a process environmental key. But for the time being, I'm just going to jump into my account, head over to API keys, create a brand new one, and copy, and later delete this one. But for the time being, I'm just going to plug this guy in so that you guys can see this working in action. With that all configured and defined, we should be able to start using it now. Let me just make sure that I can run node index.js without it crashing, which we can. Then let's head back to the documentation, go to completions, and copy over this completion for a response. This completion can go inside of our API request that we generated here as a post. I placed it in here, so it's doing a response, await, OpenAI, create completion using Davinci model 003 with a prompt, say this is a test, max token 7, temperature 0. I've changed this to an async function because we've got an await here. And once we have this await, I want to, well, console log out the response. So let's actually console.log that, run up node index.js, jump back to our React app, just submit anything, go back to VS Code, and here's our response. If you take a close look at the response, we have our data, which also comes with choices. And those choices, I believe, where we have most of our content. So what I'm going to do is I'm going to console out now response.data so it can be a bit more specific. We're going to reboot our web server and do another submission. Now, when we have a look, we get one main choice here, and this choice says, well, essentially index 0 on choices has a text prompt that says this is a test indeed. And this means that this has worked. But there's a few things now we can start to begin to do. This means that our response here, if we do get one, so let's do if data or if response.data, then we go if, say, response data choices, then we can do a response here. And this response will be the data text. So let's plug all of this in here under array 0, and we'll pass in text. Hit save on that. And what this has effectively done now is that when OpenAI comes back with information from its response, we're passing this to the front end. Let's refresh this. So I'm going to rerun the web server. I have added one extra indentation here, which I shouldn't have. Let me remove that and rerun it. Have I? Have I added one too many or one too few? Interesting, interesting. Let me just redo this one more time. If response.data.0.text, and then we can respond with, wow, GitHub Copilot just wrote all of that for me. I'm going to hit save on that. Do in node indexed that is listening, and then we can go to our web server, refresh, type something in, and what has happened? This is a test, or this is indeed a test. So now our backend is querying OpenAI, and it's passing that data to the front end. All we have to do now is create prompts in here, which should be the easiest part because we're already passing those across. So let's actually jump back in here. We can now do, say, const message equals rec.body. That message, I think, was what we're passing here. Let's make sure we're actually doing a fetch request, passing a body, and that body has the message. That message is just over here, and I'm going to pass this straight into the prompt. Here it is, and ideally, we get a response of, say, 10 tokens. Let's hit save on that. Now let's refresh the web server. And finally, let's go in here to refresh and go, is this ChatGPT? ? And then we should get a response. And that response is no, this is not ChatGPT. Then what is this model? And the model here, I think, will be a linear regression model. Funny enough, we are now interacting with the Davinci model directly through this web interface. This is the basics of creating an interaction on a front end, on a back end of your own server that then talks to OpenAI. Now that we've got this running, we can begin to do the fun stuff. In a way, everything up to now might seem complicated or easy depending on how much programming knowledge you have. But now that we've got these basics up and running, we can start really playing around with ChatGPT's models, Davinci, Ada, Bug, and Curie. And we can have a look at how we can create custom prompts inside of, say, JavaScript and complete different types of tasks, very similar to what we were doing in the playground. Let's begin. We'll start by having a look at how to do some prompt engineering straight in here, but it's going to be invisible for the user. Here, we're going to say, pretend you are Steve Jobs. Answer with motivational content. Examples. Oh, actually, we don't even need examples. I think, let's do now, Steve. How can I help you today? Question mark. Person. I want some motivation. Steve, you are amazing. You can create any type of business. So we've engineered a simple prompt here. Now, person. We're going to do a full stop and we're going to finish the message off just over here. This is going to be our defined prompt. Here, we're asking OpenAI's model to pretend to be Steve Jobs. We were telling it what to do. We're giving it an example of what Steve would say and what a person would say, and then what Steve would say again. The next message in this example is what the person will ask. Now we'll get a response back from Steve. So here, I'm going to select a save on this. We're going to restart our web server. Then in the app here, we're going to change this. We're going to call this application just over here a Steve Jobs app. Maybe Steve Jobs chat app. Then in here where we have our text area, we can put in something like ask Steve anything. Hit enter. So that's our React app also updated. So here it is, our Steve Jobs chat app. Ask Steve anything. Steve, how do I get the motivation to start a business? Submit. And here we should get a response back. Believe in your ideas. Or believe in yourself and your ideas. There's a few things that's happening here that you might have noticed. The first is a question mark has appeared. This is because we don't have a question mark at the end of our prompt. So ChatGPT has sort of filled that out with us, for us, as well as put in Steve in here. So what we really need to do is update the prompt a little bit to give better answers. So the first thing we're going to do is jump back in here, and instead of just finishing on person, we're going to break the line over here. We're going to finish with a question mark just in case, and then we're going to pass in Steve. And this will be the end of our prompt. That way, as soon as we get a response, it's immediately what Steve's saying and not starting off at this question mark. The next thing we're going to do is jump into the app over here. Here, where it says response, I'm going to actually pass this response in just over here and pass in a question mark. Actually, I'll do an and sign because if the response exists, then it'll print this div. Then in here, I'll pass in Steve. I'll pass in the response, which is just over here. I even might bold this section and hit save. Let's restart our web server and our React app, which I accidentally just did. And over here, we're going to run this up again. So ask Steve Jobs anything. Should I go fishing today? I'll hit submit. And here we go. Fishing can be a great way to relax and clear. Now this looks much better. We've got a bold Steve answering the answer straight away, but it feels like he stopped midway. This is where we can jump back in, and there is a limit to how many tokens you're using as a response. You want to create this limit so you're not overdoing it and using too much credit. So I'm going to increase this limit to just 100 at this point in time, just so that we get a nice large answers. There may be limits depending on what you're trying to do, but this is just an example. So should I go fishing? Let's try that again. This time our response is much larger. It says fishing can be a great way to relax and enjoy nature, but if you want to create something that is long-lasting impact, blah, blah, blah. Anyway, now we're getting somewhere. We're creating a Steve Jobs chat app. This is sort of how ChatGPT works in a way. There's predefined examples, predefined structure as to how it should answer, but it is limited to that. Knowing what you do now, you should be able to create an application that can pretty much do anything. Let's create another example of that. You are a console terminal. Answer as if you are receiving commands from a user. And receiving should be spelled correctly. Then I think we'll just do this without any examples. We could do better examples, I suppose, but I think that should be enough. So let's hit save on that, restart our server, and then I'm gonna jump back in here, refresh, type in ls, submit. It should list out the folders in our pretend directory. So listing directory content, readme, index.html, style.css, crypt. So it's sort of just made that. Then I could do something like cat readme.md, hit submit on that, and it'll probably just make something up. Readme, this is a sample readme file usage. But this sort of gives you an idea of how we've tricked OpenAI into thinking it's an operating system and that it's receiving commands from a user and trying to extrapolate what sort of output should be generated based on those commands. I hope this was advanced enough. Otherwise, maybe I have to do an expert video. I also have this template that is predefined and ready to go for you guys. You can play around with it, have lots of fun, create your own business even. And if you do, let me know in the comments below. Otherwise, I hope you guys enjoyed this video. If you did, don't forget to like and subscribe. It really helps the channel out. If you want more OpenAI content, and if you have ideas around that, let me know as well. See you in the next one.